Hello and welcome to lesson 3 of week 1. In this lesson, we are going to look at operators and assignment in JavaScript. My name is Mildred. Now, operators are used for mathematical and logical computations. We have different groups of operators, and we'll start with the arithmetic operator. Now, arithmetic operators that we have are the plus sign, as we saw in the last lesson, to add two numbers and also to concatenate or join two strings or a string and a number. We have the minus sign, that's for the subtraction. We have the asterisk sign for multiplication, double asterisk for exponentiation. When we do power, like 2 raised to the power of 3, we have the forward slash sign for division, we have the percent sign for modulo, and now this modulo returns the remainder of a division operation. Let's say, for instance, we have x is equal to 10 and we have y is equal to 2. If we do x modulo y, we are going to get 0. So let's say z is equal to x modulo y, and let's print this out to the output. Document.getElement by id output.innerHTML is equal to z. Right, so when we go to our web page and we refresh that, we have 0. It is 0 because there's no remainder when you divide 10 by 2. We're assuming this were 9, and we divide 9 by 2, we're going to have 1 as the remainder. So the modulo operator will give us the remainder of a division operation. We have the increment operator written plus plus like this, and the decrement written minus minus like this. Let's say we want to assign z the value of x, but we want to increment x first. So let's say x plus plus like this, and then we'll say z is equal to x. So now, instead of having the value of 9, we've incremented by 1, we're going to have the value 10 for z. The same thing with minus minus. If we say x minus minus, we are decrementing by 1, we're going to get 8 as the value. So these are the arithmetic operators that we have. We have a group of operators we call the assignment operator. We've been seeing a lot of them. Equal sign that we use to assign a value to a variable. We have plus equal like this, and this just means x is equal to x plus 9. All right, if you print out the value of x here, let me delete all of this. It's going to be x is equal to x plus 9. We'll run this and see you don't have anything printed because you have to have a value. So let's say x is equal to let. So always remember to use your let, right? Let x equal to 2. So I've been doing that x and y just because it's an example, but you declare your variable with the let keyword like this. So let x is equal to 2, x plus equal 9. This will be x is equal to x plus 9, which will now give us 11 when we refresh our page like this. We have the minus equal, which is exactly the same. X is equal to x minus 9. We have times equal, which is x is equal to x times 9. Divide equal, and we have exponentiation equal like this, which is x is equal to x raised to the power of 9. We have modulo equal also, which is equal to x is equal to x modulo 9. Alright, so you want to look at the different operators that we have and practice them to see how they are used. So these are the group of assignment operators we have. We have another group that we call comparison operators, and the result of a comparison operator is always true or false. You compare two things for equality or to get the difference, and so we use it mostly in conditional statements where we want to get or where we want to do something based on the result of the condition, or if the condition is true or if the condition is false. We're going to look at that when we get to conditional statements. So we have the comparison operator. We use double equal to ask if x is equal to 2, right? So let's do an example of this. Let's say x is equal to 7. So say let x is equal to 7. We want to compare x and another value. So we'll say z is equal to x equal, let's say 10. We should get false when we print out z here because x is not equal to 10. X is 7. So we'll get false printed out. We can use 3 equal to check for both type equality and value equality. So now it's not equal to 10, but it's of the same type, so it's going to be false. But if we do this and ask whether it's 7, yes, it's equal to 7 and it's of the same type, data type as it, so it will be true. If we now change this value, we put a quote to be a string, is now going to become false because while it is the value of 7, it is not of the same type as the integer 7 there. So we have not equal written with an exclamation mark equal. So this is going to tell you true, it's not equal, written with this and an exclamation mark, and this is going to, let's say 10, this is going to tell you true because it is not equal. If you change the condition to make it equal, it's going to tell you false, like that. Okay, so you can experiment with all of them and see the values that you expect and the values that they bring out. You can use the not double equal like this to test for both equality of type and value. Then we have other ones like we use in mathematics, greater than and less than. Is x greater than 7 is going to be false because they are equal. Is x less than 7 is going to be false because they are equal. Okay, and do you want to ask if x is greater or less than or equal to? Is going to be true because it's equal to 7. All right, the same thing with the greater. You can do greater or equal, like that. We have a group of operators that we call logical operators, and we use logical operators to combine two expressions. Let's say we want to know if something satisfies the condition along with something else satisfying the condition. We have 3 different logical operators that we'll look at. Let's do this. Let's say we have x is equal to 10 and y is equal to 5. So let x equal to 10, let y equal to 5. And then we'll say let z is equal to, we want to have x is less than 10. So we want to have 2 conditions. The value of x is less than 10, then and we want to also have y is greater than. So we'll have the evaluation of 2. X is less than 10 is false, and y is greater than 4 is true. Once you use an AND operator, if one condition evaluates to false, the final evaluation is false. So when we print out z, we should get false printed out because one of the condition fails. We have another one that is OR written with 2 pipe like this, which means that it should evaluate to true if any of the condition evaluates to true. And so I'm going to come to my web page and I'll refresh and it's going to be true. Then we have the NOT that negates the evaluation. So this is true, but if I change this to NOT with a blank sign like this, so x is less than 10, which is false, negate it becomes true, right? Or we just want to say let z is equal to, let's put a parenthesis and use not like this. And so now instead of us to get this, we'll get the reverse, false, that we got before. We have bitwise operators, and for this we want to illustrate bitwise. It's not something we use in this course, but you need to know what exists because you will need them as you go advanced. Let's say we want to have more output here. We want to look at the different bitwise operators and have this for multiple outputs. So we have these different IDs and we want to work on them here. I want to have a value of x is equal to 7 and I want to use the bitwise operators. So we have bitwise and, let me write let bitwise, let's say bitwise and equal to, and we want it to be, we use the ampersand sign 7 and 1. Then we'll have another one, let bitwise or equal to 7. So we use a single pipe. XOR, we use the caret sign. So we'll do let bitwise 7 caret, and let's say let bitwise, well let's use left shift 7 1 right shift. Let's be consistent with our syntax, equal to 7 let unsigned equal to. Okay, so we have all of this declaration. We'll look at the bitwise and bitwise or bitwise XOR, the left shift, the right shift, and the unsigned. All right, so what this does is work on the binary representation of the different operand number that we have there, and they only work on 32-bit numbers, so it converts it first to a 32-bit number. So this 7 is converted to a 32-bit number, and after the operation it now converts it back to a JavaScript number and displays it as a JavaScript number. Alright, so we want to display all of this to the output. So let's say bitwise and is equal to plus bitwise and. Then I'll copy this and do that the same for all, so we can, so the ID here is and. We want to output this to the OR. We want to output the next one to XOR. So the ID name must match. Okay, we want to output this next one to the NOT. So we have to do the NOT because I don't think I did that here. We use the tilde sign for bitwise NOT. Alright, then we have this to be left, right, then unsigned. So say left, left shift. So we have these different outputs to output to this HTML element. Let's go to our web page, refresh, and then we see all of the values. Okay, we're supposed to change the text here, and I just put bitwise and. So I can say bitwise or, bitwise XOR, bitwise not, left shift, right shift, and unsigned. So we can see all of the outputs and the values to bring. You can take the time, ponder on this. You don't need to know how it works internally, but how it works is just takes the binary representation of integers, works on the 32-bit numbers, converts them back to JavaScript numbers, and display the output for you to see. Now, operators have precedence, just like in mathematics. There is an order that these operators go. We normally have like multiplication, division evaluated before addition and subtraction, and then we have anything in parentheses is evaluated first. So you want to look at the reference document in your course resource and look at operator precedence and know what is the order of evaluation of operators if you have them in one evaluation on the page. This is where we end this lesson. Thank you.